This is what we're about to do to our routers. My daughter loves this Halloween decoration. Anyways. The control plane, the brain of our routers and our switches, our devices. We're going to remove it. Yep, you heard me right. Software-defined networking is here. Controller-based networking is going to pretty much cause a brain transplant. Let's take a look. We are moving away from the distributed control plane. No more of that business. We're taking the brain, the control plane of our networking devices, and we're going to cut it out. Scalpel! Just remove that. And remove that. Why did we just do that? What are we going to do with the brains? We're going to take the brains and give them to a controller, a big brain. We effectively just turned our devices into zombies. Our zombie network devices are now controlled by a master, the software-defined networking controller. The control plane is effectively moved up to him. In this example, this SDN controller has taken over all control plane functions. Total takeover, total brain transplant. That means that anything to do with how data flows, because they still have the data plane down here. That's still a thing. Zombies still have their bodies. They just don't control what happens. But the SDN controller controls that logic of how the data flows. So up here lives OSPF. Up here lives spanning tree. All that logic, all that control no longer belongs to the routers or the switches. It's all up there. Now, this is a complete control takeover. Software-defined networking, which is what we're talking about here. There are some situations where only parts of the control plane will be in the controller, not a full takeover. But that's essentially what software-defined networking is. We're taking the control plane, the brain, out of our devices, and I mean, we're not actually physically removing anything, but we're giving control to the software-defined networking controller. So as opposed to a distributed control plane where each router has its own brain, has its own OSPF process, and figures things out, this is a centralized control plane. The control plane has been centralized in the controller, and it controls our devices. I'm going to erase the data plane down here. We know he has a data plane, and in a lot of cases still has a management plane. We can still access these devices directly. Now let's take a step back real quick. If you recall from the skill where we talked about what is network automation, we performed a lot of automation by just using Python scripts and interacting with the devices directly. That was automation, a form of automation. It's how we've done it for a very long time. We saw how we could interact with the device with automation tools via SSH, entering CLI commands. In the skill where we talked about REST APIs and JSON, we interacted with our routers via the exposed REST APIs, all part of the management plane. But see, now with software-defined networking, we're moving away from that. We're moving away from accessing each individual device, and we're letting the software-defined networking controller control each individual device for us. So where do we come in? How do we automate things? Let's talk about that. First, let's talk about how the SDN controller controls our devices. I want to scoot this stuff over so we have some more room. Get over here, zombies. So how does this software-defined networking controller, this SDN controller, control its zombies or network devices? Well, it does it via an interface. Now, not an interface you might think, not like Fast Ethernet 1 or Gigabit Interface 2, whatever. It's more of a software interface. We call those SBIs, a southbound interface. Why is it called a southbound interface? Well, north, south. That's why, because in most networking diagrams, when you're talking about SDN controllers, the devices will be sitting underneath the SDN controller, so it's a southbound interface, right? Now let's elaborate more on what interface means. And it can mean multiple things, multiple protocols. Really, it depends on what SDN controller you're using and what devices you're using. But here are some of the most popular options we have. Now, we've already explored some of these already, like API, the Application Programming Interface. If your networking devices have API capabilities, well, your SDN controller can control it via API. Now again, this does depend on your SDN controller, which there are options, we'll talk about those, and your networking devices. Here's a list of the most popular ways for an SDN controller to control our networking devices. These are all different SBI interfaces, or SB interfaces, southbound interfaces. OpenFlow is open source. OpenFlow has been around for a while. It's an industry standard API. It's run by the Open Networking Foundation, the ONF. OpFlex is another southbound API that is used with Cisco's ACI product. Cisco ACI is how we automate our data centers. So whereas with a CCNA, you normally look at campus designs, access switches and stuff, data centers call for different designs. And Cisco ACI is the product you'll use to automate your data center. We'll talk more about that here in a moment, but they use OpFlex. The SDN controller uses OpFlex to control its networking devices. Believe it or not, don't call it a comeback, the CLI. We're talking SSH access is used by SDN controllers for one good reason. And we've talked about this before. Not all networking devices support all the new stuff. Like not every network device is going to have API support. A lot of the older devices don't have API support, right? A lot of existing Cisco equipment in a lot of companies just can't do it. So that's why we have CLI and SNMP as the option to control devices. One of the SDN controllers we're going to talk about a lot here in a moment is DNA Center, and they do use CLI and SNMP to control some devices. DNA Center is the SDN option to control the campus environment. We'll talk about more about the software-defined access, but man, DNA Center is the ultimate software-defined networking controller. We'll cover more in a moment. I don't want to give away too much. And then we have NetConf, which is also used by a DNA Center, and many other SDN controllers. NetConf, which is just shorthand for network configuration, is cool because it was standardized by the IETF. It's actually a standard, a network automation standard, which is pretty cool. So these are some of the main options for a southbound interface you'll see out there. Again, they depend on what controller you use and what devices you have available. Now, because we have a southbound interface, you might assume that we have a northbound interface, and we absolutely do. We call it our NBI, which again stands for northbound interface. So named because it is above the SDN controller in most network diagrams and such when we're talking about SDN. The northbound interface is fun because this is where we get to play. This is where we come in. This is what we access. But what is a northbound interface? Well, first of all, it can be a GUI. It can be a beautiful graphical user interface that we just interact with. Here's one right now. I'm in the Cisco DNA Center GUI, and with the software-defined networking controller that has a GUI, which most do, you can pretty much control anything with your network. If I wanted to create VLANs across my network or configure OSPF or just say I want these guys to be able to talk to these guys, I would do it through this controller. And click, magic happens. This is one example of a northbound interface. Another would be REST API. We talked about that one in our skill about REST APIs. If you haven't seen that, go back and watch it. But instead of accessing your devices directly via their own exposed REST API, we'll access the REST API of the SDN controller, which becomes powerful, and here's why. The SDN controller controls, ideally, your entire network. 50 routers, 100 switches. It'd be quite the pain to send hundreds of API requests to each router and say, okay, what's your host name, and get just all that information back. That'd be a pain. But if an SDN controller is sitting between you and the routers, you can say, hey, SDN controller, I'm going to send a REST API request, get request, and saying, get me every host name of every device I have right now, and it shoots out a list. That's one very small, very kind of dumb example because you can do so much more. We'll talk about it in a moment, but that's the power is we access the API of the controller, which gives us access to a ton of stuff. So software-defined networking is all about going from a distributed control plane to a centralized control plane, removing the brains from our network devices, if not totally, maybe a little partially, and putting it into a software-defined networking controller, and they control the show. And they do it via some southbound interfaces. You can do OpenFlow, OpFlex, CLI, NetConf, depending on what you have available to you. And then we have our northbound interface, which is how we access and interface with our network via the northbound interface of our SDN controllers. We can do it via pretty GUI, click, 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 or use our own scripts and our own programs and our everything else and just interact with the REST API of that controller. We are just scratching the surface on software-defined networking. We covered kind of how it's organized now with our northbound and southbound interfaces where the software-defined networking controller sits. And the coming nuggets will uncover more about the benefits and all the cool things we can do with software-defined networking controllers. And it solves the same problems we talked about in the what is network automation skill, where we walk through configuration problems and dealing with consistencies and human errors. All that stuff will also be solved by a software-defined networking controller, but just better, in a better way. It's so exciting. It's the new stuff. It's what we're looking at on the new horizon. And I can't wait to tell you about it in the next few nuggets. I hope this has been informative for you, and I'd like to thank you for viewing.